Welcome to this platform. So let us answer this question. The topic is circle theorem or angle properties in a circle. So here is an exam question that came in a certain year, that is ECZ, and the question reads, in the following diagram, AB and AC are tangent to the circle. Center O and AC and BE are produced, meet at D, and the angle BAC is equal to 54. As you are able to see the angle here, 54. The first question is calculate the angle ACB. So calculate the angle ACB. Where is the angle ACB? So this is ACB. Okay? So how do you find the angle ACB? So now one thing that you know, that you should know, that if you have two tangents from the external point of a circle, the distance of these tangents where they touch the circle, they are equal. Okay, so these distances are equal. Now when you have equal distances here, you think of the kind of a triangle that is formed, and that is an isosceles triangle. So an isosceles triangle is formed when two tangents from the external point of a circle to where they meet. In short, the distance from where they meet to the part where they touch the circle, they are equal in length, and therefore forming the isosceles triangle. Now one thing about isosceles triangle is that it has base angles which are equal, and the angle that we are asked is ACB, this angle here. So now we are going to consider this one as an isosceles triangle. And what are we going to do? We are going to say 180, since total angles in a triangle is equal to 180, minus 54, which is this angle. Then whatever we are going to find, we divide by 2 because these angles are equal. So if you subtract 54 minus 180, this one is going to give us what is it going to give us? Is it, let me say 180 minus 54. So this is 6, this is 7, this is 2, this is 1. So it's going to give us 126. 126 divided 2, this is the this is 6 and this is 3. So please be able to confirm that we are getting 63. So this angle is 63 degree, and also this one is 63 degree. Okay, so the angle that we are looking for, which is ACB, we are just going to subtract, we are going to find it as 180 minus 54 divide a 2, which gives us 126, divide 2, which is 63. So ACB is 63 degree. Then the other one, which is the CBD. Where is CBD? So it starts from C, then B and D. So CBD is right here. That is CBD. Now what are we going to do for us to find CBD? Another thing that you need to know is that one thing you need to know is that the radius, where the radius meet the tangent, the angle 90 degree is formed. Okay, so the angle 90 degree is formed. This is to say that the angle right here, you can see the radius, they going to the point here, the whole of this one is 90 degree. So we can say the angle between the tangent and the radius is 90 degree. So the angle between the radius and the tangent is 90 degree. So the whole of this is 90 degree. And remember we said this one is 63. So to find this part, we are just going to subtract 63 minus 90. So 90 minus 63. And what is it going to give us? This one should be able to give us a 27 degree. So this angle is 27 degree. Be able to confirm this part. Then the last angle that we are finding is CBD. CBD, where is CBD? CBD. That's what the one that we've just found. Okay, let me put, I think there's an error with the question. Let me just modify the question. So I'll put A, D, ADB. What about ADB? What is the angle ADB, which is this one? What is the size of this angle? So to find the size of this angle, the easy way, you can consider the whole of this triangle. The whole of this triangle. You know, total angles in a triangle add up to 180. So you're going to say 54 plus this part, which is 90, the whole of this, plus 90 plus this part, let us put it y, plus y equal to 180. Okay, so if we were to add 90 plus 54, it's going to give us 144. So y is equals to 180 minus 144, and this one gives us 36 degree. So this angle here is 36 degree. But please take note that these are not only approach that you can take to find these angles, quite different approach that you can take to find these angles. The other way that you can take is taking this one as 63, and now this one, you know that angles in a straight line add up to 180, so you have 63 here. You can find this remaining angle here, which is just 180 minus 63, which gives you also that is 180 minus 63. So this one gives you a 7. This one gives you a 1, so 117. So this one is 117. Then now this one we found it to be, what did we find this one? 27. So you can say 117, 27 plus 117 plus this angle that we do not have here, we can put x equal to 180. Total angles in a triangle add up to 180. You should be able to find the same 36. So quite a number of ways that you can use to find these angles. So we do not just focus or stick to one way. So there are different approaches that you can use. So please be open to look at different approaches, whichever is easy for you. So that is it about this question. Let us look at the second question. So the second question is this one. In the following diagram, A, B, C, and D are points on the circumference of the circle with a center O. BD is a diameter, as you can see, BD is the diameter, and you know that the diameter cuts the circle into two equal parts. Okay, so the diameter simply cuts the circle into equal parts. So this is the diameter, which is BD. Then we are told that AD is equals to AC. So AD, which is AD is right here, is equals to AC. So these sides are equal. And when you have the sides that are equal, in the case of a triangle, just know that that is an isosceles triangle. I think that is something that you should come to your mind. And the angle BDC, which is this one, is equals to 22 degree. Okay, what are the questions? Find BAC. Find BAC. So BAC, this angle here. Let us find this angle. Now, how do we find this angle? So this topic, you really need to look at all the possible. There are properties that we apply. So make sure that you remember all the properties. It will be easy for you. So one of the properties that we can apply, look at this. This is called the chord. It is the chord, and this part is a segment. So this is the minor segment, and we have this major segment. So the property that we can apply is that angles in the same segment are equal, or angles originating from the same segment are equal. Now, which part is originating from the same segment here? If we were to draw this part, look at it, it's originating from this segment, and also this part. So the angles that are formed at the circumference there, so this and this angle are equal. So if this is 22, also this one is what? 22. Okay, so the angle here is equals to 22 degree. Then now the other question is find CBD. Where is C? CBD. So this angle here. How do we find this angle? So for this angle, this is the semicircle. Okay, And one property of angles in a semicircle is that angle in a semicircle is equals to 90. So this angle here is 90, and we have a 22 here. We can use the property of angle in a triangle, where we say 22 plus 90 plus this angle that we do not know, we can put A, which is equal to 180. So 90 plus 22 should be able to give us 112 plus A, which is equals to 180. So A is equals to 180 minus 112. I guess this is 112. Then when you subtract there, it should be able to give you A is equals to, should be able to give us 68 degree. That is another way that you can use to find this angle. But alternatively, to find that is to find CBD, which is C, BD, this part here, we can also use that property for angles at the center, a twice angle on the circumference. That is if they are originating from the same segment. So as you can see, this part is coming from this segment, and also this one is continuing from the same segment. So this angle is half this angle, which means this one is 2x if this is x. So to find this angle here at the center, you just multiply this angle by 2. So which means this angle is 44. Now, if this angle is 44, you know that this is a radius up to there, and this is a radius up to there, and these are equal in length, making this triangle an isosceles triangle. Isosceles triangle have base angles equal. So which means these angles are equal. Okay, and we are interested in this one. So to find this and this, we are just going to subtract 180 minus 44. What are you going to find? This one should be able to give us 130. Is it 130? 136? I guess 136. Then divided 2 should be able to give us 68. So this is 68, and also this is 68. Like I said, there are quite different approaches that you can use to handle these questions. So that is how you find this question. I mean, that is how you answer, or that is how you find this angle. Then the last one, which is ACO. ACO. So which means we are just looking for this angle here. How do you find this one? Now the easy way to find this one is finding, because this one is an isosceles, which means all base angles, this part, and this part are equal. So if we can find this angle, then we can find these two angles. Okay, like I said, they are quite different methods, so you can look for the other method. So now, how do you find this angle? To find this angle, we are going to consider that this is the segment. And now this part and also this part, they are originating from the what? From the same. Okay? And here we said this is 44. So if this is 44, this is 180. So which means we can find this angle. Okay? Not necessarily what I had said, but let us go with this one. So we are saying this is 180. So 180 minus 44, we can find here, which is 136. So this angle here is 136. Now, this angle is twice the angle on the circumference. They are originating from the same segment. So this angle here is twice this one. So to find this one, we are going to divide this one by 2. And should be able to give us what? 68. That is what we had found here. So this is 68. Now, if this is 68, we are going to say 180 minus 68, then divide 2, so that we can find these two angles. 68 minus 180, what is it giving us? This one is going to give us, is it 112? 68 minus, yeah, should be able to give us 112. Let me see, 180, that is 68. We have, this is 2, this is 7. Okay, it's giving us 1 12. So 112 divide 2. This angle, the whole of this one, is giving us a z. This is divide 2. This is 5. Remainder 1, 12, that is 56. So the whole of this one is 56. And also this one is 56. Now, remember what we are interested in is just this part. So if the whole of this is 56, how do we find just this part here? Okay, remember this inside part also is an isosceles triangle of which these base angles are equal. So which means also this one is 22 and this one is 22. So now 22 minus 56, what is it able to give us? So 56 minus 22. This is 4 and this is 3. So it's able to give us 34. So this angle is 34 degrees. So could be the other way that you can find this one easily. So please be able to confirm the calculations that are accurate. So could be the other method that you can use to find this one easily. So be able to look at all that. So that is 34 degree. Otherwise, this is where we come to an end. So please get to look at some more questions, practice, make sure that the properties you have them, they are at the fingertip and you'll be able to enjoy this topic. Okay, so see you in the next one.